All right, so for quiz number 6, we're basically focusing still on radicals, okay, whether they're square roots, cube roots, that type of stuff. Nothing higher than that. So we're going to start off doing examples of what I saw on your quiz, and I'm just going to kind of throw up. I think there's 8 of them that we're going to do. Some of them will be a lot easier than others, so we'll see. So this one right here, example number 1 says 3 radical 2 minus 2 radical 3 minus radical 3. So if you guys remember, with radicals, as long as their radicands are identical, right? So I can see a cube root of 3 and a cube root of 3 right there. So those look the same, so I would say those are like terms, right? So I'll just kind of highlight them for us here. But these are like terms right here, because they have the same radicals, okay? So I'm just going to start writing out my problem here, 3 radical 2. And then negative 2 radical 3 minus radical 3. Remember, there's a 1 there, right, that we don't see, but there's a 1 there. So that's negative 2 minus 1, that's negative 3 radical 3. At this point, just double check to make sure that you can't simplify your radicals anymore. After that, you can be done.
Wouldn't it be positive or no?
Which one?
The negative 3?
No, because I'm subtracting, I'm not multiplying.
Oh, you're not multiplying?
Yeah, if I'm multiplying, then negative 2 times negative 1 would be positive 2. But I am subtracting. So again, minus 2 minus 1, if you owe me $2 and you owe me another dollar, now you owe me 3, right?
Yeah.
So it's minus 3. So yeah. So there's that one. So again, nothing too difficult at all times. Sometimes they're pretty easy, but just be aware of it. Any questions or any other questions, comments on this one? Yeah, we got 8 of them. Some will be easier than others. So you can see right here we have 3 radical 24 minus 3 radical 54. They are not like radicals because they don't have matching radicands, right? The numbers inside of the radicals don't look the same. But I can make them look the same. I just got to think of 2 numbers that multiply to 24 and 2 numbers that multiply to 54 that would have square roots on it. So again, 24, if you want to write them all out, it'll look like this. Those are all the numbers that multiply to 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Which one of those has a nice square root? Well, 3 and 8 doesn't, but 4 times 6 does. 8 has a nice cubed root. Okay? Remember, guys, your earpieces. 8 has a nice cubed root, but 4 has a nice square root. So I'm gonna use these. What about 54? 6 times 9, that's a good one right there. We can do like 2 times 27, 1 times 54. I know there's a 3 in there. What is it? 3 times 17, I think it is. But 6 and 9, those are really good because 9 has a square root. So let me put that in there here. So it's 3 square root 4 times 6 minus 3 square root 9 times 6. Okay, I know the square root of 4 is 2. I know the square root of 9 is 3. So I'm going to kind of draw little arrows to get them out. So the 4 goes out and becomes a 2. So it multiplies the 3 times 2. That gives me 6 square root of 6 minus. And then the square root of 9 becomes a 3, and 3 times 3 is 9. So it's 9 square root of 6. Well, again, check to see if there's anything else you can do. But if you notice, I have radical 6 and radical 6. They're the same thing. So I can combine them. Right? So what's 6 minus 9? Negative 3, right? So negative 3 square root of 6. And there you go. So remember, when they're not like radicals, then you can break them down as much as possible. Maybe it's possible, maybe it's not. And then once you break them down, double check. Maybe they actually do have the same radical inside, and that's going to allow you to bring them together. If they don't, that's okay. But if they do, put them together. Any questions or comments on this one? All right, so moving on. Let's do a cubed root problem. So I have a negative 2 cubed root of 5 minus 2 cubed root of 4 equals to 2 cubed root of 40. Now, 5 only has two numbers it can break down into, 1 times 5. But none of those have cube roots. 4 can be broken down into 1 times 4, but remember, never use the ones. And the only other option is 2 times 2, but 2 does not have a cube root. So that means the first two radicals I can't do anything with. 40. What number can I multiply 40, or what numbers can I multiply 40 by one of them having a cube root? 5 times 8, 8 times 5, doesn't matter which order, right? So I'm going to go ahead and use that, okay? So this will be negative 2 cube root of 5 minus 2 cube root of 4 minus 2 cube root of 8 times 5. And I know the cube root of 8 exists. What is the cube root of 8? 2. So that's going to come out as a 2. So that'll be a 2 times 2 right there. So let me rewrite this. Negative 2 cube root of 5 minus 2 cube root of 4 minus 4 cube root of 5. At this point, I'm done, but I got to double check, right? I do have like radicals here. I have negative 2 cube root of 5 and negative 4 cube root of 5. So negative 2 minus 4, negative 6, right? So that's going to give me negative 6 cube root of 5 minus 2 cube root of 4. At that point, I am done because there's nothing more I can do with those cubed roots. So that's it. So that's, I think the first three are based on the front of the test. I think the rest of them are based on the back. We okay with these? Remember, with cubed roots, guys, the numbers you're going to try to divide by with cubed roots will be 8, 27, 64, 125. These are going to be your cubed roots that you're looking for, okay? So this becomes, if you take a cube root, it becomes a 2, this becomes a 3, this becomes a 4, and this will become a 5. If you take cube root of 8, 27, 64, 125. So make sure you guys have those memorized, because that's pretty much the best way to break down any of these cube root problems, by looking at those numbers only, 8, 27, 64, and 125. All right, so moving on. So this one looks super easy, right? But as usual, there's always something that you got to do with it. So square root of 2 times the square root of 6. Now times means don't add them, right? It means multiply. And remember, when you're multiplying radicals, you multiply the numbers outside, you multiply the numbers inside, okay? The numbers outside are 1 and 1, so 1 times 1 is 1, so we're not going to worry about that. But radical 2 times radical 6 becomes radical 12. Okay, and we're done. But as usual, double check, right? 12 is 1 and 12, 2 and 6, 3 and 4. Do I have anything that has a nice square root? 3 and 4, right? 3 and 4, 4 and 3, any direction works just fine. I usually put my square root or cube root number in the front just so that it tells me like this is the one that's leaving, right? You'll notice I always tend to do that, right? So the 4 comes out, it becomes a 2. Square root of 3, and now we're done because square root of 3 cannot be simplified. So easy problem, but there's a little hitch to it, right? Like don't just multiply and leave. Like you can do more. And I think your calculators can do this one. I'm not 100% positive, but I think it can. If it can't do square root of 2 times square root of 6, for sure it can do square root of 12. Okay? So, all right, so that's 4. Now we start getting to some of the stuff that starts to look a little bit more complicated. So square root of 15 times the quantity of negative 2 radical 3 plus 3 radical 10. So we are going to have to do distribution, and you can count on the fact there will be one that you have to FOIL. I'll put that in, I think it's next. Binomial times binomial. because those are like probably the more complicated ones. But right here we have a monomial times a binomial. So we're just going to distribute. Okay, so we'll distribute this times that, and that times that. So let's start off with radical 15 times negative 2 radical 3. So that's negative 2 radical 45 plus, because 3 times 15 is 45. 3 times 1, that's 3. And then radical 15 times radical 10 is radical 150. All right. So I have two big numbers inside of those radicals. One of them easier than the other. I know 45 is 1 in 45. That's 3 times 15. What else do I get? 5 times 9. Okay, which one of those has a nice square root? 5 and 9. So, all right, here we go. Let me put that right here. That's going to be negative 2 square root 9 times 5 plus 3 square root of 150. The square root of 150 has a lot, okay? But I'm trying to think of a big number that could help me. And the first number that comes to mind is 50. But 50 doesn't have a nice square root. But half of 50 does, 25, right? This will be 25 times 6. Right? Because 50 times, what would that be? 3. That would be 50 times 3, but that doesn't have square roots. So I thought, okay, cut 50 into 25. I know 25 has square roots, so I just divided, and 25 goes into 156 times. So I'm going to use that. I'm pretty sure, I think, let's see, 3, no, I was going to say 4 I think fits, but no, it doesn't. So let me write this down. 25 times 6. So the 9 comes out, so does the 25. So this is going to be, if the 9 comes out, it becomes a 3. So it's negative 2 times 3, that's negative 6 radical 5. Plus, if the 25 comes out, it becomes a 5, so that's 3 times 5, that's 15 radical 6. They don't have like radicals, and 5 and 6 don't have nice square roots, so we're done. That's example number 5. Let me double check, see how many of these we have. We either have 7 or 8, but I'm not sure. I know we have one of those. Yeah, we have 8 because I did one with cubed roots as well. And that'll be the last one. So these are probably the last set that are going to take a while. Okay, and then the other ones shouldn't be that bad. So number 6, this is a distribution problem, full distribution. So some people like to say FOIL problem. Okay, doesn't mean that it's difficult. It's just a little complicated because there's a lot of stuff going on. So just keep your work in order, right? Use lines if you have to. I'll kind of show you that right now. Just to keep my work in order. First thing I'm going to do is multiply those two. So negative 2 radical 2 times radical 2 is negative 2 radical 4. That's the first one. Now let me multiply the same first term times this second term. So negative 2 radical 2 times 3, that's negative 6 radical 2. All right, now let's multiply with the negative 5. So negative 5 times a radical 2 is a negative 5 radical 2. Because they go together, but they don't multiply inside or outside because one of them is an outside number, the other one has an inside number, right? And the last one, negative 5 times a positive 3 is a negative 15. All right, so let's simplify. The square root of 4 becomes 2, so that's negative 2 times 2, that's negative 4. Okay, you'll note that this right here is going to be a set of like radicals, right? So negative 6 radical 2 minus 5 radical 2 is what? Negative what? 11, okay, radical 2. And then minus 15. Negative 4 minus 15 is negative 19. And we're done here. Now, I was asked last week about why don't I combine negative 19 minus 11. Remember, the only way I can combine those two is if negative 19 had a square root of 2, or if the 11 didn't have a square root of 2, right? They were either just both numbers or they both have the same radicals. Are we okay with this one? I mean, a lot of stuff going on, but just take your time, right? Draw your little lines if you need to. Write everything out cleanly, and then start simplifying. So that's number 6. All right, now moving on to the last two that are considered easier. Not to say they are, but considered. So binomial, sorry. Single term times a single term, okay? Now I am multiplying square roots here. So remember, you multiply the outside numbers first, then the inside numbers second. So I do have a 1 here. So 1 times negative 3 is negative 3. Square root of. All right, 8 times 6, 48. X times x squared, x cubed. Okay? Now I do want to remind you, since we are dealing with variables, that the index is very important. So I'm going to kind of write it right here real small, okay, a little index of 2. That means that that x cubed, I want to break it down into x squares as much as I can. Okay? So, negative 3 square root of, I'm going to put a little 2 right there. All right, 48. Give me two numbers that multiply to 48, and they have to have good square roots. I can write them out if you want. Say again? 8 times 6. 8 doesn't have a square root, but it can be broken down into one. 6 doesn't either. 16 and 3 is good, right? Because 16 has the square root of 4. So 16 and 3, I like that one. Not that 8 and 6 is bad, it just takes longer, right? We're trying to go faster. But just so you can see 48, you can do 1 and 48, which, like I said, never use those. 2 and 24. 3 and 16, 4 and, 12, 6 and 8. Those are all of them. Now, you always want to pick the biggest number with the square root. So that would be 16, right? That's the biggest one possible that has a square root. I know 4 has a square root, but 16 would probably be your best bet. So that's going to be 16 times 3, x squared x. Okay? I want the index to match this power, and then I'll take out that 16, it becomes a 4. So this is going to be negative 3 times 4 is negative 12, and this x goes out as well. So negative 12x, square root of, and then whatever is left over, that's 3x. And there's your answer for that one. Again, just take your time through it. Don't rush. They're not considered hard problems, but they are complicated, right? Like once you know what you're doing, they're really not that difficult. But when you're kind of still a little on and off, it takes time. So just do steps at a time. You don't have to rush it. You do have 14 problems on your quiz, but you have 52 minutes to do it, or 50 minutes pretty much. So you have a lot of time. You can take over 2 minutes per problem and still be okay. All right, so here we go. Last one. Now this is a cubic problem. So I know I didn't put it here, but I think I saw one on your quiz. I'm not sure, where the number inside will be negative. If the number inside is negative in a cube root, just take it out, okay? So in other words, it would be the same. See how it says negative 3 cube root of 48p squared? If it was a negative 48p squared, you could take it out, okay, and just make it a 48p squared. So just remember, with cube roots, you can do that. All right. Let's go ahead and multiply outside numbers first. So negative 3 times, there is a 1 here, right? So that's a negative 3. Cubed root of, I don't know what 48 times 12 is. Well, basically 50 minus 2 times 12. But let's just do here. 48 times 12. Let's see. 576. And then p squared times p to the third is p to the fifth. So at this point, I have to start asking myself, well, what number, for me right here, what number goes into 576 that has a cubed root? So what was the biggest number we would try?
125.
All right, so let me try dividing it by 125. I get 4.6. That doesn't work, right? What's the next biggest number besides that?
64.
64. So let's try 576 divided by 64 equals 9. So that works. 64 times 9. So negative 3 cubed root of 64 times 9. And then since the index is a 3, I'm going to write this p cubed p squared. Okay, I made sure my index matches my power, so that p is going out. And this 64 is coming out and becoming a what?
4.
A 4. Cube root 64 is 4. So negative 3 times 4, that's negative 12. This p is going to come out, so that's going to be p cubed root of what's left on the inside? 9p squared. And 9 does not have a cubed root, and neither does p squared. And this is what your quiz is going to be made up of, stuff like this. Okay? Nothing terribly difficult, but yeah, it can be complicated, right? So practice these things. Make sure you guys understand how to do it.